Let me show you how you're going to do the problems for today's work. This is also the way you should be doing all of your problems this year. So after you read the problem, what you want to do is make a drawing of the scenario that is described in the problem. This drawing should show things like distances, speeds, forces, accelerations, whatever we happen to be dealing with. This will help us visualize what's happening. So in this case, we have a 60-foot long bowling alley, and the bowling ball is going to be thrown at 31 miles an hour. So the first step we need to do is convert. So use your conversion factors to convert the 60 feet into meters. Meters is the standard that we want to use in all of our problems. Meters is the international standard for length, distance, so you always want to convert. So you'll see 60 feet, we put the feet on the bottom, meters on top, we make sure our fraction is equal to 1, and then we multiply or divide, and we get an answer this time of 18.3 meters. Now we have to convert the 31 miles per hour into meters per second. Again, we want to work with the standard units, and standard for speed would be meters per second. Meters being the standard for distance, and seconds being the standard for time. Now we want to convert, so we say 31 miles over 1 hour. We convert the miles into kilometers. There is 1.61 kilometers in a mile. We then convert the kilometers to meters. There are 1,000 meters in a kilometer. Now we need to convert the time, so we get rid of 1 hour and we turn it into minutes. I kind of ran out of room here, so I'm going to do a quick grab of this text and move it. And then my last step is I want to convert the minutes into seconds. So we'd have 1 minute up top, 60 seconds on the bottom. Again, I multiply or divide, and in this case I do both. I do the 31 times 1.61 times 1,000, and then I divide by 60 twice. Okay, that works out to 13.86 meters per second. Okay, now that I've converted, my next step is to actually solve the problem. You always have to start by writing out the equation that you're going to use in words or symbols. So speed equals distance over time. Do not just start with the numbers. Always start by showing the equation. Now at this point in the year we only have one equation, so it's not a big deal, but I want you to get in the habit, so I will deduct points if you don't do it. Write out the equation. Then plug in your numbers. We're solving for time, that's the thing we don't know, so we multiply both sides by t to get rid of it on the right. Then we do our algebra and we solve for t. And you'll notice we're going to be doing 18.3 divided by 13.86. That should be a little more than 1 second, and it does. It comes out to be 1.32 seconds. So here's what you need to make sure you have for each problem. A picture of the action that is described in the problem. Your picture shouldn't be too elaborate, but it should include any numbers or measurement that are described in the problem. Then you want to always convert to standard units, meters and meters per second and seconds. Then you want to show your formula without numbers, just in words or symbols. Then you want to show the numbers that you plugged in. Again, make sure you're plugging in meters for distance, seconds for time, and meters per second for speed. And then finally, you want to make sure that you have an answer that includes the unit that that answer is measured in. So in this case, 1.32 seconds. This is what your final product should look like. A picture, conversions, a formula with no numbers, the numbers plugged in, an answer with units.